My goal today is to teach you that gastrointestinal issues are at the core of a multi-system problem for many children with autism, and that therapeutic dietary interventions will be the cornerstone of your child's treatment. I saw many of you raise your hands that you folks are, this is your first DAN conference. It's important to understand that there are two ongoing issues. The first one is that gastrointestinal issues are still unrecognized and untreated, even in the kids with obvious problems like severe diarrhea and constipation, but especially in the children whose GI discomfort and pain expresses itself as a behavioral problem. From my experience, behavioral problems like screaming, nighttime awakening, crying can usually be traced back to an injured intestine. And the second problem is that specialized diets are still being met with great resistance. I'm in private practice about an hour from the major hospitals and diagnostic centers in Boston, Massachusetts, and at least in our area, most centers do not support dietary interventions. I don't have a lot of time, so we'll take a quick look at the research for those of you who will run into resistance from doctors, schools, relatives, or sometimes even spouses. You can find the details of this research on the ARI website and on Lisa's website, the Andy website, because we now have strong scientific support from the improvement we've seen in our children who do follow elimination diets. And the gastroenterologists and researchers are in agreement. They've found injury, inflammation, maldigestion, malabsorption, and overgrowth of bacteria and enzyme deficiencies. Dr. Horvath and the 36 children that he evaluated, and Drs. Bowie, Winter, and Kushak and the 500 that they evaluated, also found intestinal brush border enzyme deficiencies, which is this lecture will focus on. But one of the most intriguing findings in 2002 is the possible connection to gut flora. Drs. Janucci, Zimmerman demonstrated conclusively that there's an abnormal immune response to cow's milk protein, wheat protein, and soy. And 61 out of 63 children responded favorably to an elimination diet. This is a diet model. It's not the same as the opiate model that Lisa just discussed, but it's based on a variable immune response. It's interesting to note, too, that the siblings of the children also showed a sensitivity to milk. Elaine Gosho, for those of you who didn't get a chance to meet her, she was an author, a scientist, and she became a crusader on behalf of people suffering with bowel problems after she cured her daughter's colitis with diet. And like many of us with children with gastrointestinal issues, she spent years taking her daughter to a highly trained specialist, but it wasn't until she met Dr. Sidney Haas that she was finally asked the most important question. I consider it actually the most important question of what are you feeding your child? Sadly, she passed away in September, but fortunately she left behind 50 years of her research. This is one of my favorite slides that she designed. I think it's a great visual of the relationship between the gut and the brain, and it demonstrates that what happens in the gastrointestinal system can directly impact upon the brain and all of the parts of the body and your other organs. So let's take a look at the process of digestion. The role of the gastrointestinal system is to prepare food for absorption. The food contains energy, caloric energy that enters the cell, and it's changed to ATP. I tend to see triphosphate. Elaine used to call it all that power, because it is the power that runs the organs. So the point of this is, without the absorption of food, your organs can starve and metabolic pathways will malfunction. Now, in order for absorption to take place, food must be broken down into its tiniest components. So when you eat fats, they're split into fatty acids, and proteins eventually to amino acids. And in terms of carbohydrates, they must be broken down into a monosaccharide, or they will not cross over the intestinal barrier. A monosaccharide is a single sugar. It's in the form which can be directly absorbed into the body upon ingestion. So unlike other carbohydrates, it doesn't require further digestion from an injured intestine. And those foods would be fruits, veggies, and honey. A disaccharide and polysaccharide cannot be absorbed for the simple reason that they cannot cross over the cell membrane. They must be digested into a monosaccharide prior to absorption, and the key players in this process are the brush border enzymes, intestinal enzymes, maltase, lactase, and sucrase. Intestinal enzymes digest the disaccharides and the polysaccharides into that single sugar before it's absorbed. Now, we know from Dr. Horvath and Dr. Bowie's research that more than half of the children on the autism spectrum are missing the disacchardases. They're missing the intestinal enzymes that break these bonds here between the disaccharides and the polysaccharides. In fact, this this is not a great picture of this molecule. It's actually a very complex molecule, so it's pretty difficult to break down a polysaccharide. It was actually a parent who introduced me to the specific carbohydrate diet, and the last thing I wanted to learn about, both personally and professionally, was another diet. However, my child and many children in my practice were still suffering with bowel problems despite heroic efforts on parents' part to keep these kids gluten and casein free. This slide, this information, provided the answer to the reoccurring gastrointestinal issues I saw in my practice. It was not because families removed gluten and casein. Usually the kids did well. I saw well over a couple hundred children on the autism spectrum, and when we pulled out gluten and casein, we saw significant gains. However, the problem is what families were substituting. So in other words, families removed gluten and casein, but they added in corn, rice, soy, commercial gluten-free products, which are usually loaded in sugar, and especially French fries. I agree with Lisa, if you can do one thing when you get home, get out the dairy and remove the French fries. Those who are skeptical will become believers because your child will do better. So monosaccharides are single sugars, that's fruits, vegetables, and honey, and disaccharides would be milk sugar, sucrose, table sugar, and polysaccharides are corn, grain, and potatoes. So this is a French fry. So it really is still astounding to me when people say it's not okay to eat a fruit because you'll get yeast, but you can eat a French fry. So this is a cross-section of the small intestine. These things here that look like hills and valleys are actually the villi. This is where the enzymes are. When there's damage to the mucosal layer, there's injury to the villi, and enzymes of the surface of the small intestine are destroyed. Those enzymes that I just talked about, maltase, isomaltase, sucrase, and lactase. Early in this process, there's evidence that B12 is poorly absorbed, and this B12 deficiency can lead to impaired development of the microvilli, so it's sort of a vicious cycle. And the intestine usually responds by producing more mucus and making it difficult for the enzymes to come in contact with the food. So even in the children who've had an endoscopy and a colonoscopy, and they found that the kids really do have the enzymes, in some cases there's too much mucus being produced, so the enzymes are not coming in contact with the food. At first, when we heard about the specific carbohydrate diet, I thought we were going to be able to have the kids go to a gastroenterologist and see if they were missing the enzymes. If they were not, they didn't need to follow SCD, but that's not the case. In some cases, the kids have a lot of mucus, and the enzymes there are not doing you any good unless it's coming in contact with the food. So what happens when the children are missing the enzymes and they ingest complex carbohydrates? These are the identified problems that the researchers and the gastroenterologists have told us that these are the problems. Problems in the esophagus, problems in the duodenum, and there's ileum problems. Well, there is a sparse amount of bacteria in this small intestine. And this is where the last step of complex carbohydrate digestion happens. When the undigested polysaccharides and disaccharides reach the colon, this area is loaded with trillions of bacteria. The bacteria are overfed, which causes an overgrowth. And the waste products from this overgrowth produce acids and gas, which can cause many of the symptoms we see in our kids, like pain and heartburn and nausea. In the kids, especially in the kids who are nonverbal, they'll lay their bellies on the cold floor, or they'll flip themselves on a chair. But even more problematic is the acid that produced can degrade the lining of the intestine and the intestinal tract cells. This damage compromises the ability of the intestinal cells to produce the enzymes for digestion. So even less disaccharide digesting enzymes are produced, and it starts this vicious cycle of maldigestion, malabsorption, and bacterial overgrowth.